Okay, let's solve a few problems using the law of sines. So I would recommend drawing out a triangle first and labeling all of your sides and angles. You don't have to make the triangle be precise. Oops. There we go. So I'm just going to let this angle be alpha. So I've got beta, gamma. So C, A, and B. Now what I'm going to do is just label each of these that I know. So I know that this guy is 120 degrees. Again, it's not to scale, right? So, but that's all right. And length A is 7. And angle B, or beta, is going to be 45 degrees. So now what I try to do is I try to fill in all the remaining pieces that I can just by looking at it. And now I've got two angles here. So I know that the sum of the angles in a triangle, at least in our two-dimensional flat plane here, the sum of the angles in the triangle is 180 degrees. Therefore, I should be able to get gamma because I know alpha and beta. So I've got 120 degrees plus 45 degrees plus gamma, whatever it is, should be equal to 180 degrees. So that means gamma plus 165 degrees is equal to 180 degrees. Or gamma is going to be equal to 15 degrees. So we can fill that one in as well. So now what I want to do is I want to find B and C, the remaining two pieces. So I already have what gamma is. So if we solve this triangle, excuse me, if we solve this triangle, what we'll need to do is use the law of sines, and we'll take a ratio that we already know. Well, here's what I mean by a ratio. We know what we want to do is find one of these. So the law of sines is this. Okay, so that's the law of sines. I want to get one of these guys if I can. So I want to know one of these. Okay. Well, I know alpha is equal to 120, and I know A is equal to 7. So this is the one we have. Okay. So what I'm going to do is I'm going to write down the sine of 120 degrees over 7 is equal to. Now, I'm going to use that to find some of the missing pieces here. So let's say I want to find B next. So let's say we want to find this guy. Well, to find that, we need to figure out what other one has a B in it. Well, that's sine beta over B. So we'll say sine alpha over A is equal to the sine of beta, which is 45, over B. So this is the guy I'm solving for, but I have this equation. I only have one variable. So there's a couple ways you can do this. You can substitute in values that you already know from your unit circle, or you can use your calculator. Now, odds are, when you're trying to solve a triangle like this, you probably want to use your calculator because the angles, even though in this problem are nicely given, they usually aren't. So I'm going to grab our calculator. And I'm going to say, okay, what is sine of 120? I'm going to make sure that I'm in degrees. Okay, so sine at 120 degrees is that's going to be square root of 3 over 2. So 0.8, I'm going to round it to 0.86. Well, we'll do 8.66. So this is 0.866. So we'll take that number and we'll divide it by 7. And that's equal to the sine of 45, which is, we know, is square root of 2 over 2. But we'll go ahead and grab the value here. Right? So this is going to be 0.707. So 0.707, and we'll divide that by b. Now what we have to do is solve this. So to solve this, we'll take 0.866 divided by 7, and I'll get 0.124 is equal to 0.707 over b. So 0.124b is equal to 0.707. So I multiply both sides by b here. And if I continue working, I'll have b, the side length, is equal to 0.707 over 0.124. So we'll take 0.707 and divide it by 0.124. So we're getting about 5.7. Oops, I just lost my number, 0.50 or 0.57. $5.7. Okay, so that should be our length for B. And let's just take a look here to see if that makes sense. If alpha is 120 degrees and we get a side length of 7, if beta is only 45 degrees, it should have a smaller side length. Okay, so 5.7 is smaller, so it does make sense. It's not significantly smaller, but it is smaller. Now let's look at gamma. So I want to find side C. We're going to do it very similarly to what we just did. So it's usually best to use the initial side that's given to you. This helps reduce error. So I'm going to go back to sine of 120 over 7, and I'm going to say that that's equal to the sine of 15 over c. Again, solving, I'm going to do this one just a little bit differently. I'm going to go c is equal to the sine of 15 times 7 over the sine of 120. And that'll help me reduce a little bit of error that's involved here. Okay, so 7 times the sine of 15 divided by the sine of 120. So that gives me a length of, we'll say 2.09. So that says that this is 2.09. Now the same technique could have been used over here as well. We would have had the following. I just think it's worth noting that b is equal to 7 times the sine of 45 over the sine of 120 degrees. And so if I grab the calculator here and I go 7 times the sine of 45 divided by the sine of 120 again, I get 0.571. So you notice that this is obviously more accurate than what we got, but it's in the ballpark. Okay, and that's one of the reasons that we don't like to use this other one, this second length or whatever we find when we do the next computation, because you can end up with a little bit of an error there. But this is the solution. So now we've found what B, gamma, and C are, and those were our missing pieces.